Our next candidate here is Georgie Roy. Jyoti is a PhD candidate with Dr. Philip Lowe, and she's studying chemistry in the College of Science. She's from India, and she came to the United States in 2011 to pursue her degree. She did her MS in pharmaceutical chemistry from the New Jersey Institute of Technology. Some interesting facts that Jyoti shared with me is that she loves spicy food, but her love for sweets is more intense. And as she says it, yes, she is Indian, but her love for sweets is pretty intense. She likes painting, especially nature, and she loves taking pictures. She would like to thank her family for all the support they have provided, especially her parents and her husband. The title of her talk is Cancer, Targeted Drug Therapy.
Let's start. Every 2 minutes, a woman in the United States is diagnosed with breast cancer. 1 out of 8 women suffer from breast cancer in their lifetime. The current strategy to treat breast cancer is either surgical removal of the breast cancer cells or chemotherapy. But none of these methods are free of side effects. Now, for a moment, when we think about what's the most important thing when you send a package to someone, it's the address. A right address can help deliver the package to the right person. Similar to the right address, I was able to design a small molecule that can deliver a package either filled with an imaging agent or an anti-cancer drug to the right person, that's the breast cancer cells. My small molecule actually recognizes a protein that's abundantly expressed on different types of breast cancers and have very limited expression on the healthy cells. The biggest challenge with the current method of surgically removing the breast cancer cells is the inability of the surgeon to visually differentiate between the healthy cells and the cancer cells. To solve this problem, I linked my small molecule to a fluorescent dye, which can accumulate on the breast cancer cells and make them glow under the light of a specific wavelength. As you can see on the picture, in the imaging panel, the green color indicates the breast cancer cells and rest of the other cells are healthy. This method, what we call as fluorescence-guided surgery, can help the surgeon to explicitly remove the cancer cells while leaving the healthy cells. Now, let's talk about the conventional chemotherapy. The conventional chemotherapeutic drugs suffer from lots of side effects, and that's mainly because of their inability to differentiate between the healthy cells and the cancer cells. To overcome this problem, I linked my small molecule to one of the anti-cancer drugs, and it was given to a group of tumor-bearing mice. These mice showed complete cure of the cancer, and it did not show any side effects associated with the current anti-cancer drugs. It's indicated by the pink squares on the graph, whereas other group of the mice that received the conventional chemotherapeutic drugs suffered from lots of side effects and were dead after a few doses. I hope my small effort towards developing a better imaging and therapeutic agent for breast cancer cells will have a bigger impact on the long run. Thank you.
All right, welcome back. I hope you had wonderful cookies. We spent time counting ballots, and it was hard this year. Man, you guys are great. I have learned so much. I really enjoyed it. I think let's give them all a round of applause because they were awesome tonight. We have to narrow it to 3. One of the things we have in the graduate school is this plaque that will be there forever, so you can bring your grandchildren and say, see, I won, whatever. I was the People's Choice Award. That will be hanging in there. We'll add your names onto the big bang plaque for the grad school in there. The awards for these, our first place gets $500, our second place gets $250, and our People's Choice gets $250. So those of you that win, I will need to get with you at some point to get forms filled out so that you can get your money. That's really critical. The other thing of note is that we have plaques for our winners. And I will need them back too to get your name engraved, because right now they're blank. And and to prove that you have it in 10 years, you want to be able to have your name on the plaque. So we'll go ahead and get those back. So the first award I'd like to announce is our People's Choice Award. I can tell you it came down to a tie between that, and then the judges had to decide how they were going to negotiate between People's Choice, First Choice, and Second Choice. So let me go ahead and just announce our People's Choice is Heather Paisley, Growing Sustainability in Africa. Congratulations. There you go. Our runner-up this year is Fa Wang, Vitamin D, the Sunshine Vitamin.
Thank you.
Congratulations. And our first place winner of the 2016 3-minute thesis competition is Georgie Roy. Breast cancer in me, thank you. And this is a story of persistence, because Georgie was one of our contestants last year, did not place. So keep coming back, keep trying. You have a chance of succeeding. Let's give them all a round of applause. Let's thank them for their great effort. Appreciate it. So they're going to stick around for some pictures. You're welcome to stick around too and congratulate and talk with them after we get their pictures. We appreciate you all coming tonight. Please spread the word. I think this is one of the best kept secrets that we have in the graduate school about how wonderful the work is that our students are doing and what wonderful quality that they have. I will tell you, for the next year, I will be talking about all 11 of these talks and telling people what I learned about them, and hopefully you will too, and invite friends and family to come back and colleagues. All right? Thank you so much. Let's give them all one more round of applause.